طيب بسم الله الرحمن الرحيم. إن شاء الله today we are going to start chapter 4 and starting from chapter 4 we're gonna go through the layered stack one by one from bottom up. So today inshallah we are going to talk about the network access layer, and of course as you all know network access layer is divided into two sublayers, the data link layer and the physical layer. So today inshallah we are going to start talking about the physical layer. Okay, so physical layer has three basic functionalities. So we have three major functionalities for the physical layer. Number one, it actually defines how physical components are connected using media أو يعني the cables يعني media and network interface card. Okay, so the physical components, by physical component here I mean any kind of device, whether it's a network device or an end device, whether it's a router, hub, switch, anything. Any network device has any kind of physical device on the network, it has to have a network interface card to interface that physical device with the network. This network interface card connects that physical device either using a cable, using like physical connectors like RJ45, you will see that in the lab, or using antenna in the case of wireless. So this is the network interface card. So the physical layer defines how these physical components are connected using these cables and the network interface card. Now, on the network interface card is just a hardware circuit or a hardware component. This hardware component has two separate circuits which constitute the other two basic functionalities of the physical layer. One, or يعني number two of the functions in the physical layer, which we call a encoding, and the other one which we call signaling. So what is the definition of encoding and signaling, and what is the difference between them? For those of you who have watched the video, and I hope all of you did that, so what is the basic definition of encoding and signaling, and what is the difference between them? Any show of hands? محمد زيان تفضل. Code. What are these codes? These codes are what? So convert bits into codes. So what are these codes? Type. What is signaling? Okay, what is signaling? Okay, into analog signal. So why analog signal? Why analog signal? Muhammad, why analog signal? Can't we just transfer the codes directly over the medium? Why analog signal? Can we just send the codes directly on the medium? Can we do that? We can do that. We can do that. That's a political answer. Uh, no, of course not. We cannot just transfer the codes as they are. First, what are these codes? So, of course, the physical layer receives this is the physical layer. It receives from the data link layer some frames. As we said, the frames is the protocol data unit that comes from the data link layer. For the physical layer, the frame is just bits. So it receives like some bits, zeros and ones. Okay. So it deals with them as bits. So the first thing it does is that it has to convert these bits into what we call codes. Codes is a generic term that indicates either digital signal or analog signal, depending on the application. Okay. What is a digital signal? A digital signal is a signal that has fixed voltage value in a specific duration. So that's a digital signal. That's a perfect example of a digital signal. It has some fixed duration of voltage in a specific time duration. Okay. Whereas an analog signal looks like this. It does not have fixed value in a time duration. So it has variable voltage level. It has variable voltage level like sine or cosine or something like this. So the code is actually a generic term depending on the application. In most of the applications, especially in digital communication, codes are actually some form of a digital signal. Okay, in some radio applications and TV applications, these codes are analog signal. Okay, so the codes are very generic term that indicates either like some form of a digital signal or analog signal. Okay, or just a group of digital signals or analog signal. Okay, so that's encoding. Of course, on the network interface card, we have two separate circuits. Okay, we have the encoding circuit and we have the signaling circuit. Okay, so this encoding circuit uses certain schemes or techniques for encoding the bits or to convert the frame bits into these digital signals. So in the material, we have discussed two schemes for encoding. What are these codes and what is the difference between them? Any show of hands? I feel that the number of people who watch the videos is reducing one lecture over the other. Okay. The question is clear. What are the encoding schemes discussed in the material? There are two encoding schemes discussed in the material. So what are these and what is the difference between them? عبد الرحمن تيسير اتفضل. Manchester encoding. So one is Manchester encoding. None return to zero. None return to zero. Okay. So what is the difference بقى? So each bit gets converted into one or two voltage levels. لا انا ده سؤال انا عايزك انت تجاوب تقول لي 1 or 2 يعني for the two voltage levels. Okay, for Manchester encoding each bit gets converted to two voltage levels. For non return to zero Just one voltage level. Bravo عليك. Yes. So for Manchester encoding, if we have a signal that looks like this, خلينا نوسع شوية الدنيا. So for Manchester encoding, so number one, Manchester encoding. So a zero, so we receive a set of bits, as we said, 0, 1, 0, 0, 1, 0, 0, and so on, right? So encoding, by the way, can work on 1 bit at a time, or can work on 2 bits at a time, or 3 bits at a time to convert it into a code. In our course here, we talk about only encoding schemes that converts each bit to 1 or 2 voltage levels. So Manchester encoding takes each bit, one single bit, and convert it into 2 voltage level. So the 0 will be converted into 1 positive. So let's say that this is the origin. Okay, so the 0 will be just positive and then negative. Okay, the 1 will be negative first and then positive. Okay, so each bit will be converted into 2 voltage levels. Okay, the non-return to zero, this is the most primitive encoding scheme, and it actually converts each bit into 1 voltage level. So the 0 is just 0 voltage. Okay, and the 1 is just positive voltage. As easy as that. So very simple, very easy. Okay, so that's the Manchester encoding and the non-return to zero. So Manchester encoding in many systems, it's better, even though it converts each bit into 2 voltage levels. Okay, so we'll talk about why Manchester encoding is actually better in that sense. Type. How about signaling? So signaling بقى talks about the fact that signaling is function number 3 for the physical layer. So signaling, as Muhammad was saying, signaling, it converts actually these codes بقى, which could be digital signal or analog signal, it converts it into another form of analog signal. Okay, so why do we not transfer the codes directly over the lines? The problem with that is that the lines are physical cables. These physical cables cannot deal with digital signal in any way. It cannot deal with digital signals in any way. Okay, you have to transfer the information over the cable as analog signal with certain properties. Okay, so for example, if we're talking about copper cables, they deal with what type of signals? Electric signals. Okay, if we're talking about fiber optics, they deal with specific type of signals, which is optical signals, right? If we're talking about wireless, they deal with microwave signal. We talked about this before. So all these are some sort of analog signals with specific properties. Not just normal analog signals. These are analog signals with very specific properties. So electric signals, they have certain frequency properties. They have certain, limitations on the values and so on and so forth. They have very important and very distinct characteristics. Optical signals, also, they have higher frequency. They have properties in terms of diffusion, diffraction, deflection, and so on and so forth. So they have certain properties when it comes to communication. Microwave signals, they also have the same, or different properties. So signaling here talks about the fact that we transfer the codes, okay, into some form of analog signal that can be transmitted over the specific cable that we use. واضح كده؟ So that's also part of the network interface card. So there is a hardware circuit on the network interface card that is responsible for converting the codes into analog signal of some specific properties that are suitable for the cabling that we are using. Okay, so any question about this? So these are the basic functionalities for the physical layer. One, it actually defines how these physical components connected together using cables and network interface cards. So for us, as far as the physical layer, a source and a destination are two network interface cards, nothing but that. Okay, so it all comes down at the physical layer to two network interface cards. They are communicating together. Okay, that's as far as we are concerned in the physical layer. ماشي. Number two, encoding. Number three is signaling. Try to interact using voice, please. I will not be able to trace all the messages. If you have a question, just raise your hand and ask the question. Okay. So this brief introduction will get us through the next. محمد تفضل. In Manchester encoding, no, we don't use that Manchester encoding in that case. We use multi-level return to zero or non-return to zero schemes. We use different schemes, basically. Okay. The straightforward answer is that for converting two bits or 3 bits, we use different schemes, not necessarily Manchester encoding. By the way, for computer engineering students who will take Network 2, maybe 1/3 of the course of Network 2 is about encoding schemes and signaling schemes and all of this. So here we only talked about two very basic ones. In Network 2, we'll talk about a lot more. We'll spend a huge amount of time on explaining these techniques in more details with all the properties and so on. ماشي كده؟ طيب. So now we'll try to get back through the upcoming activities, which will give us more understanding about the difference between the encoding schemes and network. Yeah, before I get to that, for signaling, by the way, we also have schemes similar to the encoding schemes. So we also have two schemes discussed in the material when it comes to signaling. What are these? سيد زبير تفضل. Okay, what is the difference between them? برافو عليك. Yes. For amplitude modulation, we have fixed. Yes, برافو عليك. The amplitude changes according to the input signal. برافو عليك. Yeah, that's a perfect answer. We similar to encoding, we have different schemes, but in signaling, the schemes are mapped to the basic characteristics of any signal. For any signal, we have 3 basic characteristics. We will focus on 2 of them, which is amplitude and frequency. As we all know, any signal has 2 distinct, or at least 3, but we'll talk about 2 اللي هما frequency and the amplitude. So the signaling schemes, we have frequency modulation, which tries to vary the frequency of a carrier signal. A carrier signal is a predefined signal with fixed frequency. Okay, so we'll take this fixed frequency signal, and then we try to vary the signal, vary the frequency of that signal based on the amplitude of the input signal. And we'll see how this is done. Amplitude modulation talks about the other way around. So we will fix the frequency of the carrier signal, but we will play around with the amplitude of the carrier signal. Okay, and we'll also see how this is done in the next activities. So the first activity here talks about converting specific set of bits, okay, that are coming from the data link layer, okay, using Manchester encoding. So we need to define, of course, for Manchester encoding, by the way, feel free to just map the 0 and 1, okay, in any way, but they have to be opposite to each other. They have to be a mirror of each other. Okay, so for example, you can map the 0 to positive first and then negative. Okay, which means that the 1 is negative and then positive, or the other way around. It doesn't matter, but they have to be opposite of each other. So for non-return to 0, it's very simple. 0 is 0 and the 1 is positive voltage. Okay, so this is for non-return to 0. It's very simple, and this is actually one of the advantages of non-return to 0. So most importantly, why the specific one is better than the other? So which one is better and why? That's what we need to answer. So I'll give you 1 or 2 minutes, and then if you have the confidence about solving this, particularly number 3, I need you to articulate and talk about the difference, which one is better, which means what are the advantages of one over the other. Okay, if you have the confidence about talking about this, raise your hand. I'll give the chance. I will even allow you to share your screen and try to draw the Manchester encoding and non-return to 0. If you do this, you will get the bonus. Okay, so I'll give you 1 or 2 minutes, and if you have the confidence, just raise your hand, and I will give you the chance to solve the activity. Okay, so for the non-return to 0, I see no volunteers to solve that activity. So we'll go through them together. So in the first part, the encoding for Manchester encoding, we have 0, and then 1, and then 0, 0, 1, 0. Okay. So as we said, the 0 will start the 0 with positive first and then negative. So it will be like this. So this is the 0. 1 will be negative first and then positive. Then the 1 will be positive first and then negative. And then another 0, which will be positive first and then negative. So the signal will be like this. Okay. And then the 1 will be negative and then positive, and then the 0 will be positive and then negative. So that's how the signal looks like. Okay. So as you can see, these are the boundaries of the bits, which are very important. Very important. These boundaries of the bits, we'll talk about them now. And that's how the signal looks like. Okay. Does anyone have any question? Nice. The second one is the easiest يا عبد الرحمن يعني is the easiest يعني مش محتاجة بس هو if you have good confidence to answer this one, I can give you the chance to do that, because this one requires really good understanding of what you have seen in the video. If you can answer this, then I can give you the chance. The second one is very easy. So the 0 is just 0, and the 1 is positive voltage, and then the 0 is 0, and then 0 is 0, and طبعا ده 0 1 0 0 1 0. So and the 1 is positive and the 0 is 0. Very easy. Okay. So now which one is better, do you think? Which one is better? Do you have a guess? Which one is better? Which one is more widely used? Manchester encoding is more widely used. Why بقى? Why? In order to answer this question, we have to get to some يعني ايه معلش بقى computer architecture stuff, and apologies to people from computer science. Uh, so we have to talk about يعني signals from a bit of a low level يعني. So if you have a transmitter, this is a transmitter, and that's a receiver. For us, these transmitter and receiver are just two network interface cards, which are integrated in any physical component, whether it's a hub, end device, mobile, anything. We don't care. For physical layer, it's just two network interface cards. طبعا the transmitter here sends the codes in a form طبعا of signal and stuff, but it tries to send the codes which are digital signal, which is the digital signal that looks like this in some way. Okay, the receiver wants to receive this digital signal on the other side. In order for the receiver to receive that digital signal on the other side, it needs to achieve two objectives. The first one is that it needs to recognize these bit boundaries, okay, accurately. Okay, that's very important objective. That's what we call synchronization. So synchronization has to be achieved between the transmitter and the receiver. So the first objective is that the receiver needs to identify in this signal, what are the bit boundaries? Is it in the middle here of the signal, or is it here, or what? It needs to identify these bit boundaries. That's very important. Okay. Type. So what do we use to synchronize the transmission of any two communicating parties? What do we use? We use a very important يعني component inside any hardware circuit, which we can use for synchronization. What is this بقى يا شباب؟ حد عارف؟ ليه؟ ايوه يا هاني. كلوك، برافو عليك يا هاني، صح. تمام. So the clock is just it's a form of a digital signal that gets generated internally بقى inside the hardware circuit. Okay, any kind of operation, whether it's بقى computation, any kind of operation, takes one or more cycles of this digital clock. Okay, same here. Okay, so these clocks, if they are identical between the transmitter and the receiver, okay, we can achieve perfect synchronization, in which case we can recognize these bit boundaries correctly and accurately. Okay, unfortunately, in reality, these are not equal. That's the biggest problem now. So the biggest problem is that no matter what you do, these clocks are not identical, and they have certain properties that makes them shift from each other. Okay, so that causes lack of synchronization. طيب, how do we يعني what is the consequence of this lack of synchronization? So if we assume مثلا none return to zero, and we have like four bits like this, okay, and all of them are zeros, just to make it simple. Okay, so these are 4 bits, which means 4 signal durations. Each one of them is 0, which simply means that if you use non-return to 0, the signal that has been sent from the transmitter to the receiver, it looks like this. It's 0 all the way. Very simple. It's a 0 signal, fixed signal. 0, that's it. طيب, what is the problem with this? If the clock on the receiver side is not identical to the clock on the transmitter, what might happen is something like this. The receiver says, okay, I have the bit boundaries look like this. This is 1 bit, That's another bit, and this is another bit. Okay? So you see the problem here is that the receiver recognized this line, this straight line, to have only 3 bits and not 4 bits. Why? Because the clock here, the clock at the receiver side, no matter what you do, is different from the clock on the transmitter. The frequency is different. Even if you try to synchronize them, after some time they will drift from each other. They will lose this synchronization, no matter what you do. So the consequence of this is that the 4 zeros have been recognized at the receiver as 3 zeros only. Okay? Type. So what is the conclusion here? The conclusion is that clocks are mandatory to preserve the synchronization, but they are not sufficient. If you're using clocks and you're using something like non-return to zero with a straight zero voltage that does not tell you anything about the bit boundaries, then you can lose synchronization easily. Type, what do? We need additional piece of information other than the clock to give us more information about how can we recognize these bit boundaries. What is this additional piece of information? It's actually the signal itself. It's the digital signal itself. It should tell me, okay, whether we are synchronized in terms of bit boundaries or not. Okay, how can this digital signal give me any information about synchronization? The rule is the more changes you have in the signal, the better, because if you have changes in the signal that looks like this, okay, I can see that change. I can see that change and say, oh, okay, that usually happens in the middle of the signal. So I can, in fact, readjust my clock to synchronize with the digital signal. If the digital signal is a straight line like this, that doesn't tell me anything. Okay, so one of the advantages of Manchester encoding is what we call self synchronization. So when the signal has changes in the middle of every bit, okay, the signal tells me extra information that I can use to resynchronize our clocks every now and then, and that's good. Okay, so imagine even if you have straight zeros for Manchester encoding, what would you do? You have to have a change in the middle of every bit, right? You have to have a change in every single bit, and that change is good because it actually gives more information to the receiver to readjust its own clock and synchronize this clock with the transmitter clock. ماشي كده؟ مفهومة النقطة دي؟ So the first advantage is that Manchester encoding has self-synchronization. طيب, what else? Manchester encoding also has, because of this change and because of the fact that the difference between the positive voltage and the negative voltage is big, okay? The Manchester encoding has another advantage, which is noise resistance. Noise resistance. So, in fact, another environmental phenomena that happens to the digital signal while it's being transmitted is the added noise. So, all the environmental objects around us, they cause somehow some noise to be added to the signal. Okay, so so this noise will make the signal to look like this, to be like this. Okay, so this signal will be received at the receiver side. If we receive a signal like this and then we take a look at this bit, for example, assuming that we have we have synchronized the bit boundaries perfectly and everything is fine. If you look at this part, for example, is this 1 or 0? The receiver might be confused because the value of the signal here is positive. It's not actually 0. So in that case, the receiver might get confused. However, for the case of Manchester encoding, the noise might cause the signal to be received like this. So it will be like this. Okay. So even if the noise added causes certain noise to the signal, for the Manchester encoding, it's still more resistive to this noise, better than the non-return to zero. Okay. ماشي كده. So that's the advantages of Manchester over the non-return to zero. طيب, does this come for free? يعني does that mean that Manchester encoding does not have any disadvantages? Of course not. It doesn't happen. So there's no free lunch. يعني nothing comes for free. So there has to be some disadvantages. And the disadvantages for Manchester encoding is that, one, it's more complicated, of course. Because of course, converting each bit to 2 voltage levels makes the transmitter and the receiver both complicated, of course. That's a no-brainer. But also there is another disadvantage here, is that making more changes in the digital signal increases the frequency of the signal. Of course, the more changes you have in the signal, the higher the frequency will be. So Manchester encoding has more or higher frequency requirements more than the non-return to zero. Non-return to zero, if you have a straight signal, zero, okay, the frequency of that signal is zero, so it's very low. Whereas if you have straight zeros for the Manchester encoding, you have to have a square signal that looks like this. And this signal has higher frequency components. Higher frequency requirements for the signal, in fact, increases the bandwidth of the signal. The bandwidth requirements of the signal. And we'll talk about bandwidth in the next lecture, inshallah. We'll talk about the basic definition of the bandwidth in the next lecture, inshallah. So these are the advantages and disadvantages of Manchester encoding. However, of course, Manchester encoding is more widely used, and it's used in many Ethernet standards, which we will talk about in the next chapter, inshallah, Ethernet. So Manchester encoding is by far more widely used compared to non-return to zero, which is very simple, but it's very prone to noise and does not have any kind of self-synchronization, in which case the quality of the transmission will be very bad. طيب, signaling. For signaling, we talked about two basic schemes as well. We talked about analog modulation, okay, and frequency modulation. For both of analog modulation and frequency modulation, just pay attention to the fact that this carrier signal is actually given. It's part of the signaling circuit. So it's stored in the signaling circuit. So I have a reference signal called the carrier signal, okay? And I have an input signal which represents the code that comes from the encoding circuit. So the encoding circuit will give me a code. Just not to get confused here, in the material, they use a code that looks like an analog signal, even though we have been talking about code as digital signal, okay? So the material is somewhat confusing in that regard. So that's a code. The code could be a digital signal, like for the case of Manchester and non-return to zero, or it could be an analog signal. Analog signal for applications like TV, radio. Our voices in radio is transferred as analog signal. It's not transferred as digital signal at all. So So the modulating signal is actually a form of a code from the encoding circuit, and it comes sometimes as an analog signal for applications like radio and TV and so on and so forth. Okay. Type. So that's the input signal, and we have the carrier signal. We have to mix them both, okay, using one of these two schemes. واضح كده؟ So we for the analog signal, what we try to do is that we will take the carrier signal and we'll try to change its amplitude here based on the amplitude of this modulating signal. In other words, if the amplitude of the modulating signal is low, the amplitude of the carrier signal will be low. But when it gets high, the amplitude of the carrier signal should increase proportionally. Okay. For the frequency modulation, the amplitude of the output signal or the frequency modulation signal is fixed. So amplitude stays the same. And then we take this carrier frequency and then we change its frequency. This frequency gets tighter or gets wider based on the amplitude of the modulating signal. ماشي كده؟ So so the difference here is somewhat easier because for amplitude modulation, the frequency of the carrier signal stays the same, but the amplitude changes. Okay, so the difference here, we know it. So for amplitude modulation, so amplitude fixed. The amplitude varies, and frequency fixed. Whereas for frequency modulation, the amplitude fixed and the frequency varies. The frequency of the carrier signal, of course. Okay. Type. So I'll give you 1 or 2 minutes, and then we can talk about how we represent the carrier signal using amplitude modulation and frequency modulation. Okay. So anyone has the confidence to solve that activity? Okay, so to make it easy for amplitude modulation, the first thing we normally do is to take this signal, take this modulating signal, and shift it in the positive domain. Okay, and I will tell you why we do this in a minute. So the first thing is that this modulating signal will look like this. Will look like this in the positive domain. Okay, so this is the same signal, like the modulating signal, but it's actually shifted in the positive domain. So now we need to try to draw the analog, the carrier signal, okay, and change its amplitude based on the modulating signal. Okay, so it looks something like this. So first we will start the carrier signal, okay, with small amplitude, and then we will increase this amplitude okay. So that's how it looks like. So that's why the modulating signal becomes like an envelope over the carrier signal. So it looks like this, okay. And then we get to the higher amplitudes of the modulating signal, in which case we start to increase the amplitude. But the frequency of that signal stays the same, okay. The frequency of the carrier signal stays the same. As you can see, they are equally spaced, okay, and so on, okay. Now for the frequency modulation, the envelope is actually fixed because we have fixed amplitude, and then we take the carrier signal and we change its frequency based on the amplitude of the input signal. So the amplitude of the input signal starts small. So how do I represent a signal with low frequency? I make the cycle wider. Okay, so it looks like this. So the first is we start with a wider cycle like this to indicate low frequency. But then the modulating signal amplitude starts to increase. So we need to increase the frequency gradually. Increasing the frequency means that we have to make the cycles tighter and tighter and tighter. So it becomes something like this. Then we make it very, 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 very tight to indicate that this is the peak amplitude. And then we start to increase gradually again. Okay, and then we have to make it tighter and then wider and so on. Okay, so here the frequency goes from low to high and then low to high and then low to high to be proportional to the amplitude of the modulating wave or the modulating signal. واضح كده يا شباب؟ Any question? Any question? Okay, so that's the encoding and signaling and the difference between them. طيب very quickly بقى we will solve بس ال upper part, only the upper part, and the lower part can talk about next time إن شاء الله. So just يعني a few seconds, I'll give you a few seconds to just match in the box the definition with the term on the left hand side. Okay. So synchronization, signaling method, frame encoding, asynchronous, and physical components. اتفضل يا ناصر. So the hardware devices, media, and connectors which transmit and carry bit signals. That's a physical component. تمام. تمام. So how ones and zeros are represented on the media? It varies depending on the encoding scheme. طبعا يعني أكيد it's not the encoding scheme. So it's إيه بقى؟ signaling methods. تمام. Okay. So evenly spaced time duration for signals. Synchronous. تمام. So synchronous here talks about the fact that we have evenly spaced or equally spaced duration for each bit. تمام. A method for converting streams of data bits into grouping of bits predefined. Encoding. تمام. تمام. And of course the other one is a arbitrarily spaced time duration is asynchronous. تمام. ناصر عبد الوهاب. تمام. اوكي. طيب خليني بقى ايه stop